Hi everyone, in this lecture video I am going to discuss about IR spectroscopy. The IR spectroscopy is often used by chemists, pharmacists and researchers studying molecular structures. It is used to identify functional groups and molecular composition easily, and why it matters is it's because it helps in drug development, quality control and material analysis. Users want reliable and non-destructive way to analyze the compounds. So IR spectroscopy is basically used to analyze the compounds and especially its functional group. Suppose if we have a mixture of phytochemical or something from our plant extract or some other drug composition of various formulations, then with the help of IR spectroscopy we can easily find out what is the molecular composition of that compound. So with the help of that we can easily identify the functional groups that are responsible for producing that particular pharmaceutical activity. Then what is IR spectroscopy? So IR spectroscopy studies how molecules absorb infrared light to reveal their structure. So with the help of electromagnetic radiations, the molecules will absorb some radiation at some frequency. So with the help of that radiation we are going to reveal the molecular structure. IR light lies between visible and microwave regions in the electromagnetic spectrum. So we all know the electromagnetic spectrum consists of various light radiations, and among them IR is also one of them. And this IR, that is infrared, lies between visible and microwave regions, that is from 800 nanometer to 1 micrometer. IR is a fingerprint tool to identify molecules based on their unique vibrational patterns. So since each molecule will consist of unique functional groups, its absorption is also like a fingerprint, that is it will be unique for each and every compound. It is widely used in pharmaceuticals to detect the functional groups and confirm the compound's identity. So as you can see, the IR light source will provide the light radiation ranges from 800 nanometer to micrometer, and this will pass through the sample, and the sample will absorb the IR radiation, and the amount of radiation absorbed by the sample will be detected with the help of detector, and the further the graph will be recorded with the help of recorder. Then principle of IR spectroscopy. So what is happening in IR spectroscopy is the molecules have some energy, that is electronic, vibrational as well as rotational energy. So each and every molecule will consist of all these energies, because the molecules will have the electrons and the electrons will be having spins, and because of that the molecule will exhibit some electronic energy, and it has vibrations also, because the molecules consist of atoms that are connected with the help of bonds, and those bonds were considered to be flexible. They are like a spring, so as they are flexible they will be moving, so so will experience some vibrations. And those bonds are also rotational, so while rotating they will have some rotational energy also. So when IR light matches a molecule's natural vibration frequency, it is observed creating peaks in the IR spectrum. So we are going to pass the IR radiation into our sample, and what will happen is our molecule is also having some energy, and when this energy matches with the IR's frequency, then it will be observed. The key requirement is a molecule must change its dipole moment to absorb the IR light. That is, your molecule has to be polar. Example, carbon dioxide is asymmetric stretch creates a dipole, making it IR active. Then conditions for IR absorption. A compound can be analyzed by IR radiation only if there is a change in the dipole moment during vibration. So that is, your molecule should exhibit positive and negative ends, and that those charges will be separated at a distance to exhibit some dipole moment. So only if there is a dipole moment, then the compound will become IR active. For example, if we have a molecule of oxygen, it consists of two atoms, O and O, and they both are having similar charges, and they will not be kept at a distance, and they will not exhibit dipole moment. So those compounds or those molecules are considered to be IR inactive. And also there should be a resonance between applied and natural IR frequency. For a vibration to be IR active, the transition moment integral must be non-zero and the photon's electric vector must align with the dipole change. Symmetric molecules do not absorb IR radiation. So overall, if your compound wants to absorb the IR radiation, it has exhibit dipole moment, and its applied frequency should match with the natural frequency of the molecule. So that is when the absorption will take place. Thank you.